OS's venture. Or team point. Go over.
Linear equation in X.
Okay. You should upload it. Let's really get a chance.
Oh, yeah, sorry.
You need to plug it.
No, it's AB. And
Yours is older.
it's you see that okay? Zoom in.
Yeah, yours is way older than.
Yeah. A, B, and C are constants. Oh, the long one?
Yeah.
And A not be zero. Then the linear equation in X is an equation that can be written in the form leaves the word AX plus E equal to C. That's a very basic linear equation in a single variable. Okay. So no y, there's x.
Oh, like that.
Addition principle.
I scored.
Quality. If the same. Algebraic expression. Is added to both sides added to both sides of an equation. The new equation has the same solution as the original
Is that,
equation. What's up?
is that, that can be submitted in the form,
First part or second part?
the first part?
Can be written in the form. Yeah. Can be written in the form. All right, so basically in layman terms, right, you have an equation, add something on both sides, the solution does not change, it's still the same. So if A is equals to B, so let me write the other part. Symbolically, Put away B and C are algebraic. Algebraic expressions. Then the equation A equal to B and A plus C equal to B plus C have the same solution. We'll just formally define that property, right? We can add stuff to both sides. All we're doing. Procedure for solving. Linear equations. X plus B equal to C. I'm just gonna shorten it here for this type of equation. Number one. Find like terms. On both sides. That's the first thing you should do. Check if there's anything that combines. Number two. Do the addition. Principle. Of equality. The opposite. Of the constant. E. Both sides. Equation. The objective is to isolate the variable on one side. Of the equation. It doesn't matter which side, but usually we choose the left. Technically doesn't matter. Three. Check your answer. For the variable in the original equation. And
You,
what's up?
can you go back to?
Oh, sure, yeah. All right, plenty of time today. Right here.
Or can you go down?
Just a sec. This part? Yeah, Jersey.
The, yeah, the last, yeah.
Go and write these notes next before we write the examples, get them all out of the way. Let's go on this page. Yeah. No worries, man. Got tons of patience. All I got. Multiplication or division. Principle of equality. Basically, very similar to the one we just wrote down, just for the times and division. Let's go and write it out. But if both sides were multiplied by or divided by
Your password.
the same non-zero constant.
That's the money.
You can multiply by anything you want on both sides, just not zero. And do zero. Any the same non-zero constant. The new equation has the same solution. As the original symbolically. If A, capital A, B, and C are algebraic expressions. Is any non-zero constant. Then the equations A equal to B and look at the original A equal to B, and you multiply both sides by C, you get this, right? Where C is not zero. And A over C is equal to B over C. Where C is still not zero. And these equations have the same solution. The last one.
What was that? That was somewhere.
Procedure for solving. Linear equation. Simplify.
So what?
AX equal to C. One. Same deal, combine like terms. On both sides. Number two. Or division. Principle of equality. Multiply
No buzz. I'm like, I spend like $70 to see that fight.
both sides
All I know is you won.
of the
Like,
equation.
decision. Did you buy that? Bro, I would never buy that fight. I don't watch boxing like that.
By the reciprocal.
Move it up a little bit.
Of the coefficient of your variable. Basically, it's saying you have a 2x, you're trying to get rid of that 2 and multiply it by a half on both sides. That will cancel the 2. Yeah, you flip it over. Or you can divide both sides. By the coefficient. A lot of people think of it this way, but you need to know both. And we all know that 2x on there, you can divide both sides by 2. Right. The coefficient of the variable will become a positive 1.
Does it say +1?
Yeah.
Mhm.
Finally,
Mhm.
check your answer. By substituting. Putting it for the variable in the original equation. The
Damn. Like it's 3 days. It's my dad shit. Okay. No, but he's if you. Usually, it's some of them. Senator Chicago. So you do. We got them all happen. I guess shit. No will. I will. Fuck your left back. Sorry. I want to pack up my cherries. So what? Press keep right.
What time is it? Wait, this is the longest we've been ready for.
Yeah, a lot of them, right? We gotta fill out the notes, that's what they want us to do. Let's talk about the basics of solving an equation. Pretty sure you've all done this at some point. So let's. Nothing. It's fine. Okay. The efficient way to do this. Right, it's using those principles they talked about. Which is fine.
I won't let you run on the screen or what?
Yeah, it's kind of weird. I don't feel like wasting any more time. Figure it out some other time. All the linear equations. Form. Plus. Officially, you can add any constants to both sides in order to solve for x. You choose whatever you want, except essentially we want to isolate the x. But step one said the procedures. Check if there's any like terms before you start. You're nothing that combines, right? What number do you add to both sides to isolate x?
Hold on, how'd you get -7? I'm 7, I'm so lost.
So this is the question. It starts off just like this. So x minus 3 equals 7. Solve this guy. Solve for x. That's what we're doing. So.
The minus is negative edge minus 12.
Yeah, that's done.
Good one.
Okay.
She's on my.
Okay. So the idea is to cancel the -3. So you should add +3 to both sides. So technically what happens, right? Now, I know you all done this before.
Yeah.
+3. 7 + 3. These cancel, isolating your x. Correct? That's how we do it. Now, after doing this so many times, I just like to think of it as I'm gonna move this over and change the sign. So anything that crosses the equal sign, we'll just switch to opposite sides. Some people this makes more sense. You can think about it however you want. This is the official thing that's happening, right? Mathematically, this was happening. And so I moved the 3, so it became a plus. 7 + 3. The -3 was in my way, so I moved it. It will switch whenever you move it across an equal sign. That's I know it's basic to some of each, but we're starting from the bottom. We're gonna work our way up. Be patient. Yeah. If you want me to crank up the difficulty, I always can. Don't complain. Okay. Well, they did say we have to check it. So they want us to do that. Even though I hate doing that. They want us to check it. You said it. Yeah, that's the procedure said. On like terms, you add things to both sides until the x is by itself. We have a +1 on the x, which means it's solved for, right? It's invisible. So now test it. Plug it in. So plug in x is equal to 10 into the original. 10 minus 3 is 7. 7 equal to 7. we have equality. Whenever you see that, it means you have a solution. This is telling you that it is. You get a false statement, then yeah, the whole thing is, the answer is not correct. Okay. There's no solution. Yeah. Okay. That's true. Two. You guys think? It's gonna be. Will you do yours?
No. I'll do 5 on both sides, right?
So then those fives are gonna cancel, right? If you want, you can skip that other step. And go to here. That's okay. To show the addition part. We'll look at the concepts.
Yeah. Good. Again. Actually, that one critical.
All right, number one. You said true or false? Algebraic questions added. Both sides of an equation. The equation has the same solution as the original. Is that true?
Your billing. What is it getting to, like, record? Yeah.
Because number, the addition rule says you can add those algebraic expressions and it won't change. It will still have the same solution. That's true. Number two. Also defining as the solution to the solution set, the equation is called simplifying the equation. Is that true? What do you call it?
Like over here.
True.
Think about it, right? When you're solving a problem or an equation. You usually use the word solving. Solving it. When there's an actual answer, we're solving. There's no answer, you're just messing with stuff. Simple. That would be false. Three, a linear equation in X is also called a first degree equation. That's. What does first degree mean? Do you remember? I don't think it was mentioned. Yeah. Do you remember hearing about it? Second degree, third degree. Degrees of a polynomial. That sound familiar? No. Completely foreign word. So if the highest power of any polynomial is your degree. So if you have like an x squared and that's the highest one, quadratic type. Or you could say it's second degree. If the highest is one, being just a regular x, then it's linear or first degree. Okay. It's just some terms. Number 4, equations with the same solutions are said to be equivalent equations. That can be very complicated. Just to keep it simple, if something is equal, then they are also equal. But equivalent does not mean they are equal. That makes sense? It doesn't go both ways. If it is equal, then we can assume equivalency. If it is truly equivalent, we cannot assume equality, but we're not going to get deep into the weeds of what that means. That's like high-level math, fast calculus. But just know that. Okay, they're not necessarily the same. Equality is more powerful and strict than equivalency. Okay. But if you change the equation, it is technically equivalent to the original. That's all it's saying. Alrighty. Take a short break. It is 4:15 pretty much. Come back at let's say 4:25.
Hey, sir, were you in the military?
No, it was not.
We're a lot of like military shirts.
Yeah, you really do.
There were gifts.
Oh, nice. I like them.
I have the hat of the you're wearing.
I don't even know who it is.
I forgot where I got the hat.
Whenever I have this shirt in the game, they always thank me for my service.
Thank you for your service, sir.
Alright, welcome.
Bro, thank you for being the best teacher. Word goes to you.
I almost joined the Air Force.
Really? Why didn't you?
I was on the fence for a while. But. Oh yeah, I think that's up. Wasn't ready to leave, I guess. Leave home. Using the x equal to 1, determine that whether or not it's a solution. Okay. There's one is you don't want to plug it in. That's it. This equals negative 3. With 1 minus 2. 1. Negative.
Negative.
Is that a true statement? X equals to 1 is not a solution. That's all I gotta do. Make sure you remember all the rules about signs and et cetera. Okay.
Because you don't have to rush.
That,
6. Oops, -10. Plug in this guy. That'll be -10. True. Plus -4. Yeah, it looks like it, right?
It'd be a solution.
-10 plus -4. They're gonna be.
Why do you do it the long way?
What do you mean? What's the short way? True statement. It's easy to do. All right. This is. Number 7, they want us to solve. I'm beyond. Any question on number 6? All they want us to do is plug it in and. That's it. Here, what would you do first?
Press 6 on both sides.
Plus 6. So we get x equal to 7, right? Let's skip a step. They want us to check, so plug in 7. Is this indeed equal to 1? That's all, right? So far, straightforward. Nothing crazy. Skip to 9. Number 9. 51 equals 71y. Oops, dyslexic. 17y. What would you do first? Yeah, we gotta get rid of that 17 times y. So you have to do the opposite. Either multiply by 1/17 or divide by 17. Right. So divide both sides. Coefficient, that's the rule. Of 17. multiply by the reciprocal of 7. One over 17. Combine both sides. That's it. 17 prime. Looks like it. What about 51? 51 prime? Three goes in there, right? But not 17. So. Three times 15 would be. We go any further? Three times what is 51?
Fifty-one divided by 17.
Yeah, it looks like it goes in perfectly. I didn't think it did. Yeah.
It's 30.
Anyway. Questions so far? For 10 is when the reciprocal is better. You still could divide both sides by that same number. But if you do the reciprocal here, it makes more sense. What is the reciprocal of 5 over 7? Yeah, the reciprocal means you just flip it over. That's all. So use the reciprocal instead. Both sides. Oops. Yep. You mean where is it?
Yeah.
Good question. The variable either on top with the 5 or next to it. Times 5 sevens. Well, those are the same. Okay. So 5x over 7 is the same as. Here you can see they're gonna cancel, right? So 7 times 5 over 5 times 7, they're all gonna go away. 7 times 65 over 5. I don't want to multiply anything. We get pretty big. 55 is going to 65 though. We're left with 7 times 13. We did that earlier, no? D1?
Yeah.
you would have done it the other way, divide by sevens. You have to remember the rule for dividing fractions. It flips anyway. Right? The rule tells you to flip it. So multiplying by the reciprocal, let me skip the step. Any questions on 10? Make sense? Japanese writing system consists of 3 sets of characters. So 81 characters. Non-Japanese students must know. And the third with kanji, there were 50,000 characters. With only some are used in everyday writing. The student knows 2107's total characters, solve the equation. Determine the number of kanji characters the student knows. You see how they set up the equations? The way they created it is what matters. Right. They said they had 2 different systems, but I think it's called what is it? The kana and hiragana, right? They're both, according to the problem anyway. There's 81 characters in each, and then there's the kanji. So 2 times 81 because there's 2 alphabets for those. X is how many kanji, and the total that student knows is 2107. But we saw for actual know how many kanji he knows because you're removing everything else, right? The logic. 11? First. You gotta deal with the like terms, simplify things. So it's 2 times 81. Oh, 162. The next step. We got a plus 162, so minus 162, right? We're gonna just move it over. What's 2107 minus 162? What is it? You guys got 1945? That's how many kanji he knows. Me, when I first started doing, I think when I took this class, way back when, me creating this equation was the hardest part. Like learning how to do that, it's practice. But they're giving it to you, then you just solve it. Eventually, you get to a point where you gotta like, create that and solve it. I've always found it to be difficult. But you guys see where it came from, right? How they made it. Number 12. You guys cool on 11?
Yeah. Well, it's.
Right, so a nurse must give a patient 800 milliliters of intravenous solution over 4 hours. This can be represented by the equation force equals 800. The amount of solution the patient receives per.
Dude, I just want a Camaro. I already found one, dude.
But this one they're actually questioning, do you understand why it was created this way? Do you see the multiplication of 4x? Do you see why that was chosen? Part A.
He wants me to get this ultimate. Dude, I want to drive an ultimate. It's a throwaway driving car. Nissan? Yes, Nissan.
I have to get I have
You had to?
I have
You have two?
Yeah.
When you drive it.
You guys see why was chosen.
You have two cars.
For the X again? It says the amount of solution per hour.
It's not searching.
Needs to give the patient 800 milliliters in 4. 4x is equal to 800. That makes sense? So how would you solve it? Divide both sides. It's 800 divided by 4, is that?
200. And then it's return.
What is represent that?
Insurance.
200.
Sure.
Insurance.
This patient needs to receive 200 milliliters per hour. Right, that's what this means. Got it. That's something else. All right. Let me open up the homework. We'll stop here, the lecture. Which homeworks do you guys need right now?